Alright, today we'll try to find the LCM of numbers, two or even three numbers. Let me start with this example. Find the LCM of, say, 6 and 8. Okay. So what you do is you go to this side and write down 6 and 8, and now you ask yourself, is there a number that goes into both 6 and 8 evenly other than 1? 2 does. So you say 2 goes, and 2 goes into 6 3 times, 2 goes into 8 4 times, right? Now you have 3 and 4. Ask the same question. Is there a number that goes into both 3 and 4 other than 1? Nope. So when you reach that stage where there is no number other than 1 that goes into the two numbers, you just simply multiply all the outside numbers, and that's your LCM. So LCM in this case happens to be 2 times 3 times 4. 2 times 3 is 6, 6 times 4 is 24. End of the story. Cool? Let me do another example. How about LCM of 18 and 24? Okay, so as before, let's write 18 and 24 on this side. Now, is there a number that goes into both 18 and 24 other than 1? Well, several numbers go, right? 2 does, 3 does, and so does 6. So if you can think of the biggest number that goes into both of them, use that. But if you cannot think of the biggest number, that's okay. For example, all you can think of is, say, 2. Well, 2 goes 9 times, 2 goes 12 times. 9 and 12. Is there anything that goes into 9 and 12? Well, 3 does. Good. So put another L and say 3 goes 3 times and 3 goes 4 times. Now, is there anything that goes into 3 and 4? Nope. So you just simply multiply all the outside numbers out. So that is 2 times 3 times 3 times 4. 2 times 3 is 6, 6 times 3 is 18, 18 times 4 is 72. So guess what? The LCM is 72. Okay, let me revisit this one. I'll work the same thing out, but this time, like I said, what if I could think of the biggest number like 6 that goes into both 18 and 24? In that case, you have 6 going into 18 3 times and into 24 4 times. So you already hit the stage where 3 and 4 are what's called relatively prime, which means only 1 goes into both of them. That's what it that's what it means to say that 3 and 4 are relatively prime. Okay. So as before, LCM is just simply the product of 6 times 3 times 4. 6 times 3 is 18, 18 times 4 is 72. We got the exact same answer. Cool? Alright. What about 3 numbers? Oh, say I have to find the LCM of 8, 12, and 18. So in this case, we do this. 8, 12, 18. Is there a number that goes into all 3 of them? Well, 2 does. So go ahead and divide by 2. 2 goes 4 times, 6 times, and 9 times. Now, 4, 6, and 9. Is there a number that goes into all 3 of them? Unfortunately, no. Well, of course, other than 1. So in that case, you ask this question. Is there a number that goes into at least 2 of them? 2 does. 2 goes into 4 and 6. Well, I'm sure some of you are going, well, 3 goes into 6 and 9. Good, good. But if you saw that 2 goes into 4 and 6, use that 2 and 2 goes 2 times, 2 goes 3 times. What about this 9? Since 2 does not go into 9, you have to do something weird. You just copy it the way it is. Do not go 2 goes into 9 4.5 times or 4.5 times like that. Just leave it alone. Just copy it the way it is. Alright? Now, again, is there anything that goes into all the 3? Nope. Is there anything that goes into at least 2 of them? Yes, 3 does. 3 goes into 3 and 9. So go ahead and divide by 3. Once again, the fact that 3 does not go into 2, you do the same thing. That is, you just copy it the way it is. So 3 goes 1 times, 3 goes 3 times. Now, is there anything that goes into at least 2 of them? Nope. That's where you just simply multiply all the outside numbers. That is 2 times 2 times 3 times 2 times 1 times 3. 2 times 2 is 4, 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24, 24 times 3 is 72. Ta-da! That's it. Cool. So this is the procedure. Now, if you want to stop right here, that's fine. But for the people who are more interested in, especially if you happen to be a teacher and you want to know why does this method work, right? So here is the idea. Now, what I'm going to talk about is a little bit on the theoretical side. And if you don't understand this, don't worry about it. Okay, here is the idea. Why does this procedure work? Well, recall that, let me put it this way. Let L be the LCM of A and B, and G be the GCF of A and B, the greatest common factor. We know that there is a property that says L times G must be equal to A times B. Right? The product of the LCM and the GCF of two numbers must be equal to the product of the numbers itself. So according to this, this implies L must be AB over G. So the LCM of two numbers A and B must be AB over G. Now let's demonstrate this with our method. In our method, we say A and B, and then we ask, is there a number that goes into both A and B? Well, the fact that G is the greatest common factor, G must go into A and B. That's why we call it the greatest common factor. It's something that goes into the numbers, right? So G will divide both A and B by G. When we divide A, we get A over G, and when we divide, we get B over G, right? Now, because we divided both A and B by the greatest common factor, A over G and B over G must be relatively prime. That means there is nothing other than 1 that goes into A over G and B over G. There cannot be a factor other than 1 that goes into A over G and B over G. Well, that's the stage where we say, hey, multiply all the outside terms. The LCM L will be just the product of all the outside terms. G times A over G times B over G. G's cancel, and AB over G as desired. So we showed earlier that LCM of A and B is AB over the greatest common factor G. So that's what we. Now, why does this? What if you don't divide by the greatest common factor? Let's say it turns out the greatest common factor itself can be factored into as G1, G2. Okay? Now, in our process, if we say AB, G1 goes into both A and B. Right? So A over G1, B over G1. Now, these are not relatively prime. In fact, G2 you will find will go into A over G1 and B over G1. Therefore, we'll divide by G2. And when we do, we get A over G1, G2, comma, B over G1, G2. Right? However, since G1, G2 is the greatest common factor, A over G1, G2, B over G1, G2 must be relatively prime. So we have hit this stage where we simply multiply. LCM is G1, G2 times A over G1, G2 times B over G1, G2. G1, G2, they cancel. This is AB over G1, G2. And this in turn is equal to AB over G as desired. End of the proof. Cool? Alright, that's all I wanted to say.